Um, Today's lesson is looking at calculating probabilities using z-scores and specifically looking at the left tail. So probabilities of the left tail is we've actually looked at the probabilities of the right tail so far. So we've got our mean, this is our z value, and we've looked at the areas there. So the left tail is exactly the same, and we know from the last lesson that it's pretty much the same question as finding the right tail, because the normal distribution curve is symmetrical. So if these z's are the same value, except the one on the left is negative, they'll be the same answer. So let's take a look. So we've got sheep weights are normally distributed with a mean weight of 84.1 kilos and a standard deviation of 4.6. What is the probability that a randomly selected sheep has a weight less than 83.042? So following our steps, draw the picture. So we've got our mean again, which in this case is 4.1, standard deviation, which is equal to 4.6. We've got our 83, which is less than 84. And we're trying to work out that area. So what that's going to mean is that our our table is going to give us this area. So we have to take this area away from what the total of this half probability is. So when we get at the probability from the table is we will have to take that away from 0.5 to get what that is. So the next thing is to calculate our z-score. So again, z is equal to 83.042. Take away 84.1 divided by 4.6. So we chuck that on our calculator, which gives us minus 0.23. So then we use that on our z table. So 0.23. That gives us a probability, or this area being equal to 0.1293. So now to work out our final probability, or that shaded area, we have to go 0.5, which is half the data because it's below the mean. Take away 0.1293. So if we quickly do that on our calculator, 0.5 gives us the answer 0.3707. That leaves us with the last step of our question. Last step to answer the question is to write the probability in context. So the probability of a sheep being under 83.042 kilos is 0.3707. So 37%. As always, I've got a second question here for you. The density of a Panama is normally distributed with a mean of 3.3 grams per cubic centimetre and a standard deviation of 0.011 grams per cubic centimetre. What is the probability that a randomly selected piece of Panama's density is less than 3.2912 grams per cubic centimetre? So pause the video, have a go at the question, see how you get on. So pause the video now. Okay, hopefully you had a go at that and you've got an answer. So let's see how you did. So first thing, draw the picture. Okay, so we've got our mean, standard deviation, and the x value that we're trying to find the area for. So calculate the z-score. Here's our formula. So z is equal to 3.2912, take away 3.3 divided by 4.6. So do that on our calculator. I suddenly realized in my haste to get the answer that it's not 4.6 for the standard deviation rule, it's 0.011. It shouldn't be 4.6 up here, 0.011. So we should get negative 0.8 as our z-score. So looking at the chart, we get down to 0.8. It's 0.80 because there's no second decimal place. So that gives us the probability, or this area is equal to 281. And then that means that the probability of x being less than 3.2912 must be equal to 0.5, take away that area that we got from the table, 0.2881, which gives us a final probability of 0.2119. So again, the last step is to give that some context, which we can do. So the probability of having a density that's less than 3.2912 grams per cubic centimetre is 0.2119. So that should have been the answer we got. So to summarise, first thing is draw a picture, calculate the scores using the formula, look up the probability in the table, write that probability in context. What does that mean? So the probability of x being less than is, and so on. So if you could go back to your lesson page, work your way through, there should be a worksheet that you need to complete and a couple of pages of the workbook, and then that should be it.